Coronaviruses are a group of viruses covered in little protein spikes that look like a crown, or corona in Latin. There are hundreds of known coronaviruses. 7 of them infect humans and can cause disease. The coronavirus SARS-CoV causes SARS, MERS-CoV causes MERS, and SARS-CoV-2 causes the disease COVID-19. Of the 7 human coronaviruses, 4 cause colds, mild, highly contagious infections of the nose and throat. 2 infect the lungs and cause much more severe illnesses. The 7th, which causes COVID-19, has features of each. It spreads easily, but can severely impact the lungs. When an infected person coughs, droplets containing the virus spray out. The virus can infect a new person when the droplets enter their nose or mouth. Coronaviruses transmit best in enclosed spaces where people are close together. Cold weather keeps their delicate casing from drying out, enabling the virus to survive for longer between hosts, while UV exposure from sunlight may damage it. These seasonal variations matter more for established viruses, but because no one is yet immune to a new virus, it has so many potential hosts that it doesn't need ideal conditions to spread. In the body, the protein spikes embed in the host cells and fuse with them, enabling the virus to hijack the host cell's machinery to replicate its own genes. Coronaviruses store their genes on RNA. All viruses are either RNA viruses or DNA viruses. RNA viruses tend to be smaller, with fewer genes, meaning they infect many hosts and replicate quickly in those hosts. In general, RNA viruses don't have a proofreading mechanism, whereas DNA viruses do. So when an RNA virus replicates, it's much more likely to have mistakes, called mutations. Many of these mutations are useless or even harmful, but some make the virus better suited for certain environments, like a new host species. Epidemics often occur when a virus jumps from animals to humans. This is true of the RNA viruses that cause the Ebola, Zika, and SARS epidemics, and the COVID-19 pandemic. Once in humans, the virus still mutates, usually not enough to create a new virus, but enough to create variations or strains of the original one. Coronaviruses have a few key differences from most RNA viruses. They're some of the largest, meaning they have the most genes. That creates more opportunity for harmful mutations. To counteract this risk, coronaviruses have a unique feature, an enzyme that checks for replication errors and corrects mistakes. This makes coronaviruses much more stable, with a slower mutation rate than other RNA viruses. While this may sound formidable, the slow mutation rate is actually a promising sign when it comes to disarming them. After an infection, our immune systems can recognize germs and destroy them more quickly if they infect us again, so they don't make us sick. But mutations can make a virus less recognizable to our immune systems and therefore more difficult to fight off. They can also make antiviral drugs and vaccines less effective because they're tailored very specifically to a virus. That's why we need a new flu vaccine every year. The influenza virus mutates so quickly that new strains pop up constantly. The slower mutation rate of coronaviruses means our immune systems, drugs, and vaccines might be able to recognize them for longer after infection, and therefore protect us better. Still, we don't know how long our bodies remain immune to different coronaviruses. There's never been an approved treatment or vaccine for a coronavirus.
As you know, the important thing now is to look after ourselves and others. That's why many measures have been taken. To avoid the spreading of the virus, it is advisable to follow some hygiene standards. Wash your hands very often or use hydroalcoholic gel. Did you know that this way the material that envelops the virus is broken? If this material is broken, the virus can't infect the cells. Be careful with the objects you touch, and avoid touching your face. Keep a safe distance from others to protect yourself and them. If you use a mask, be careful not to touch it once you've put it on. The mask should cover your mouth and nose. Cough or sneeze into your elbow. Research is very important to be able to solve all our doubts. Moreover, we should thank all those people who are working and helping so that we can get back to normal.